Hey guys, welcome back to Explore Electronics. This video is about solutions to the model question paper of the subject 8051 microcontroller. So let us get into the first question. Bring out the differences between microprocessor and microcontroller. Here, before going to the differences, let me give you an example so that you can remember easily. Microprocessor in the sense, if you have a personal computer, that personal computer or a laptop will be having Intel or AMD processor. So that processor will be a microprocessor. With that, it will be having RAM externally, it will be having hard disk, and also all other supporting components external to that processor. That is a kind of microprocessor. It means it is a CPU with additional RAM, ROM, and timers and other things. But you can take an example of your scientific calculator. That is an example for microcontroller device, where that calculator will be having a microcontroller inside. That controller itself consisting of RAM, ROM, everything. The microcontroller application will be in a smaller way. Microprocessor will be like a bigger way. So we can understand the differences now. CPU is standalone here in microprocessor. RAM, ROM and timers are separate and are interfaced to the CPU. And in microcontroller, it will be having a CPU, it will be having a RAM inside, it will be having a ROM inside, and also timers, all present in a single chip. But in microprocessor, all are externally connected. And we say microprocessor is a versatile device and general purpose. Versatile in the sense, it will be adjusted to any kind of RAM or ROM you are going to connect externally. But microcontroller is not versatile. Why? Because it is having its own RAM, ROM. It will be compatible with only that. And microprocessor can have expensive applications. Means it will be used for expensive applications. You can use it for any applications, like you can install any applications in your system like that. But microcontroller is particularly for the particular application, and it is designed with respect to the cost, power as well as space criteria is considered. And large number of instructions with flexible addressing modes there in microprocessor. It is more flexible with addressing modes, and also number of instructions are more. But in microcontroller, it is limited number of instructions and few addressing modes are there. And designer can decide the amount of RAM and ROM required to connect with the processor in microprocessor. But as I said, microcontroller will be having a fixed amount of RAM and ROM and also IO ports. And access time for the memory and IO devices is more here. Why? Because the RAM, ROM are connected externally, while processor communicating to the ROM and RAM, the time requirement is more. But in microcontroller, RAM, ROM are present inside a CPU itself. That's why here access time for the memory and IO device is less. So microcontrollers are fast compared to microprocessors, we can say. And very few instructions which are having bit handling capability in microprocessor, but in microcontrollers we can have many instructions with bit handling capability. So these are the differences, main differences between mu-P and mu-C. It can be asked for 5, 6, 7 marks. Depending on that, you need to write the points. Coming to the second question, this is again a difference between CISC and RISC kind of processors. CISC in the sense, remember again before going to the differences, first you need to understand CISC and RISC explanation. It means CISC in the sense complex instruction set computing. Means the instructions are complex here. And RISC in the sense it is reduced instruction set computing. Means the number of instruction set here it is reduced instructions, means less instructions. So coming to the differences, CISC and RISC you can expand and write as a first difference. Then it consists of large instructions set to perform many type of operations. You can see CISC in the sense complex instruction set. It means complex means more. And RISC instructions are small instruction set to perform limited operations. And you can write one more difference is that it can perform different types of many operations, but it can perform only limited operations. Simple instructions take multiple machine cycles for its execution. And this in RISC, simple instructions require one machine cycle for its execution. Means the execution will be fast in RISC processor. And then frequent memory access is there in CISC. Memory accessing is not frequent in RISC. And variety of addressing modes are there in CISC, fewer addressing modes in RISC. program size is smaller here, and comparatively the program size is larger here. Because the instructions are less, we require to use the same instruction again and again to get the functionality. That's why the program size becomes more in RISC and the number of instructions are less. But here the number of instructions are more, so the program size will be reduced. And no need of specified compiler design in CISC, but efficient and optimized compiler design is required in RISC. And complex decoding circuit is necessary here, and small chip area needed for the instruction decoding and sequential control. Means coming to the decoding part, it is the complex circuit is not required in RISC. Here the complex decoding method is required. And instruction pipelining is absent here in CISC, and in RISC instruction pipelining increases the execution speed. Here the pipelining is there. And coming to the CISC, as I said, the examples are Intel 8096 family, 8086 or 8085, and Motorola 680X0 family are the examples for CISC. So microprocessors or Intel microprocessors are under CISC. And you can see ARM processor, Motorola 88100, Alpha, AXP are RISC kind of processors. These are the differences. Coming to the next question, 1C, that is again very important question. This question is also repeatedly asked, and every time when microcontroller question paper if you see, you will see this question. With the neat architecture diagram, explain the architectural features of 8051 microcontroller. Here for 10 marks, you need to write this diagram, architectural diagram, and also you need to write the explanation. Explanation carries more than 5 marks here, and other 5 marks will be for the diagram. Here you need to explain the first thing is the 8051 microcontroller is 8-bit controller. Why? Because whatever the data process in this controller will be of 8-bit data. You can see over here, ALU performs the operations on 8-bit data. That's why A, B are the registers. A is accumulator and B is the register, which can hold a value of 8-bit. But the address which we are going to take for ROM as well as RAM will be of 16-bit. Remember this should be the first point. 8-bit address it can handle. That's why it is called as 8-bit device. And it will be having 16-bit bus address. Address bit will be 16-bit. That's why address bus is 16-bit. And data bus is 8-bit. And we will be having program counter, and we have DPTR, and also we have RAM and ROM here internally, and you need to specify the size of the RAM and ROM also. And we have 4 ports for IOs, port 0, port 1, port 2, port 3, consisting of 8 IOs, 8 pins each. And then coming to the other registers, there are special function registers, instruction pointer, there are PCON, SCON, TMOD, TCON, and these are all required for the special functionality. Interrupt handling as well as for the different functionalities, you can see these are the special function registers available. You need to explain these. And there are different banks available, register banks, each containing 8 registers, and you can see, and this is byte addressable and bit addressable. And also to handle the interrupts, we have system interrupt timers are there. System timing and control will be done by this ALE, address latch enable, and PSTN, XTA, L1, L2, reset, VDD, ground. All these need to be explained. These will be connected to ports. So this much of explanation is minimum required to get 5 marks fully. So at least 1 page of answer is required here for the explanation, and you need to write this diagram clearly. And then coming to the second question, that is the choice question. Here they have expected the internal memory structure and programming model of 8051. So out of these 2 questions, one is architecture, otherwise they will ask the internal memory structure for sure. And you can see here, the left side we will be seeing the memory and the division. The internal memory will be divided into special function registers as well as internal RAM. Internal RAM will be from 00 to 7FH. It means it is of 128 bytes. You can see here internal RAM is 128 bytes. So each and every location in your memory can store 8 bit of data. That's why it will be having 128 locations, and each locations will carry 8 bits. That is a byte. And these bytes in each and every part of the RAM are bit addressable. Means the address of each and every bit is available. You can fetch a particular bit from the location. So if you say it is 2CH is this location, where the bits are in the position 60 to 67. You can fetch a 67th bit individually. That is called as bit addressable. Byte addressable in the sense, if you give this address to CH, complete byte of the byte value present over here will be available. So that is the one thing you need to explain. These are bit as well as byte addressable. And 7FH in the 0 to 7F in the sense, it is 128 locations are there. Each can store 8 bit of data. And then we have a ROM. That ROM will be 4 KB of size. You can see here, this is internal RAM, ROM 000 to FFF indicating 4 KB. And the programming model in the sense, you need to explain all the registers present and also the RAM structure as well as the ROM structure, and also the different ports, which port is corresponding to which pin, and how to take the inputs from those ports, and which are the IO ports and which are all the special ports you need to explain. And also the stack pointer, PCON, SCON registers you need to explain, and also the instruction pointer and other things related to the programming. This much is for the question. Internal memory structure is at the left side here and the programming model at the right side. And then the next question is, write an interfacing diagram of 8051 microcontroller interfaced to 8K bytes of RAM and 8K bytes of ROM. And this is the 8051 microcontroller. So this 8051 microcontroller will be interfaced to ROM as well as RAM in the sense, it will be connected through the ports. All the external devices will be connected through the ports only. You can see 8K into 8 ROM in the sense, it is this of size 8K and it will operate with 8 bit value, means the data will be 8 bit. So that's why the data pin is, you can see here from port 0, pin 0 to 7 will be for the data, and those are also act as address. You can see here, this is a kind of address picker or decoder to fetch the address. And the other things, write, read, chip select and all will come from port 2. And this much is for the ROM as well as for the RAM. You need to explain 8 bit. This is also 8 bit. It requires address and all. So write, read pins are come from the third port. You can see. So this is the interfacing diagram for the 8051. Here the main thing is to explain the ports as well as size of the address as well as data, and which are all the ports connected to address and chip select, read, write signals. Then comes the third question in second question C. Write a short note on the criteria for choosing a microcontroller. How we are going to choose a microcontroller in our project or in our application. The criteria is that the amount of RAM and ROM available on chip. Why? Because microcontroller will be having inbuilt RAM and ROM. So depending on our application, we need to choose by looking at the RAM ROM size also, and also the power consumption of that, and number of IO pins present. In 8051, you can see the ROM and RAM we have seen over here, it is 128 bytes and 4K, and also we will be having 32 IO pins. Similarly, the other microcontrollers will be having different RAM and ROM as well as IO pins and timers also. So looking at that, we can choose. And also its flexibility to upgrade to the higher performance or lower power consumption versions. So here you have seen the interface diagram. So this 8051 will support 8K, 16K also, RAM and ROM. So this kind of external devices, how we can connect and what is the maximum flexibility it has for high performance and low power consumption we need to see. And also cost per unit and speed, and whether it is available for dual in package or it is quad flat package we need to see. So the third A question, explain 5 different addressing modes of 8051 microcontroller with examples. So in the question itself, they have mentioned 5 addressing modes with examples. So immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and relative addressing modes can be explained like this. So these are the 5 addressing modes. In immediate addressing mode, we will be having an immediate value will be specified with hash. So move a comma hash 99 can be used. Then register addressing mode. Register addressing mode will be used for add a comma R5 like that. R5 is a register here. R0 to R7 registers we can use over here. If the instruction consisting of that R or R1, R2, R3, R4, any of R0 to R7, we can call it as register addressing. Then direct addressing mode, we can give an example like move a comma 47H. So here 47H is the internal RAM address. So we are using the address and the content will be moved to A. And then indirect addressing. Indirect addressing in the sense we need to specify the value present in the register as address. So it will be an address present in R0. So A comma R0 in the sense content of R0 will be directly moved to A, that is register addressing. So the indirect addressing is that we are going to use @ that specifies the memory location address present in that register. And relative addressing mode used only with certain jump instructions. So the relative address is given and the jump instruction which in the example which I have shown here, it is JZ. These are the 5 addressing modes you can explain with examples like this. Then we have a assembly level program question. Write an assembly language program to multiply 16-bit number with 8-bit number and store the result in a memory. Here 16-bit number we need to multiply with 8-bit number. So remember all the registers we have for R0, R1, R2, R3, R7 are 8 bits. So 16-bit number in the sense we need to take two 8-bit numbers and then we need to multiply with the other 8-bit number and we need to store it in the memory. So for that we need to define the memory locations first. You can take the 16-bit number and 8-bit number directly, or you can use the memory locations like this for storing those numbers also. So lower byte of 16-bit number, higher byte of 16-bit number and 8-bit number taken into 3 memory locations defined over here. Num1 high, low indicating the lower byte and the higher byte of first 16-bit number. It will be multiplied with 8-bit number that will be taken as num2. And the results you can see result low, result mid, result high will be stored in 33H, 34H and 35H of the memory. Now you need to write the program. First we need to multiply 2 8-bit numbers and store it, and then we need to multiply another 2 numbers and we need to store. That is the logic behind this. So first multiplication and the second multiplication and the final storage will be the 3 main steps over here. You can see the explanation also given over here so that you will be understanding each and every line clearly. And while storing it in the memory, you are supposed to use result high, result mid, result low. Otherwise, if they specify particular register over there, in place of result high, mid and low, you can use those registers. Then the next question, 3C, write an ALP, assembly language program, to convert packet BCD number into 2 ASCII numbers and store the result in R5 and R6 respectively. Here also, if they want to store the result in register R5, R6, you are supposed to use first ASCII number into one register R5 and the second ASCII number into R6. If they mention like store it in particular memory, in the previous case how we took the memory locations defined, and the same way you can do here also. But in the question itself, here they have given store the result in R5 and R6. So we need to store the first ASCII number after adding it with the 30H to convert into ASCII. We need to place it in R5, and then again we need to take the second digit and then we need to place it in R6. This is how we need to write the program to convert BCD number to ASCII numbers. Then we have one more assembly language program question. Write an assembly language program to add 16-bit numbers loaded in R1, R0 and R3, R2 and store the result in R6, R5, R4 from MSB to LSB. Here you need to understand 2 16-bit numbers you need to take. So 2 16-bit numbers in the sense we need to take the LSB byte and the MSB byte separately. So the 2 registers we require, and then we need to load it in R1, R0 as they have given and R3, R2. R1, R0, one 16-bit number, it takes 2 registers. R3, R2 will be the second 16-bit number. You need to add them and then you need to store it in R6, R5 and R4. So here is the program given and also the comments are added for the better understanding. Then let us move on to the next question, 4B. Explain rotate instructions with examples. So this is the kind of question where they ask instruction set related questions. You may ask other instruction set also. Here the rotate instructions are asked. The answer should be like this. Here the complete answer is given. So you need to follow this way to explain any instructions. Rotate left instruction, rotate left through carry, rotate right with carry. RLA, RLCA, RRA, RRCA. So it will be operate with an accumulator. So you can explain what actually the instruction is and then the operation, and then taking the example and rotate with one bit left right like that with carry without carry. You need to show the result. So this is how you can explain this instruction set question. And then we'll be having a next question like explain the following instructions. Also mention how many bytes it takes to store it in ROM. So the 4 instructions are given here. So for this question also, other than simply writing it will take 2 bytes, 3 bytes or 1 byte like that, you need to explain a little bit. All the questions, including a program questions, require some bit of theory explanation. Means in the programs you need to write it in comments. In the explanation like this questions, you need to explain briefly each and every things. DJNZ, that is decrement and jump if not 0, will take 2 bytes, one for opcode and one for the relative address. JNC address or address, that is jump if no carry, it will also take 2 bytes, one for the opcode and one for the address. And then DAA, that is decimal adjust instruction, it will take 1 byte only for the opcode. And then MOVX A comma at the rate A plus, this is an move external instruction. So it will take 1 byte in ROM for the opcode MOVX. So this is how you need to explain the instruction, what it will do and what are all the other things required to perform that operation and how many bytes it will take to store it in a ROM. This is question number 5A. Explain mod 2 operations of timers and explain steps involved in programming timer in mode 2. So this is the diagram you need to write. Here it is indicating TL, TH registers and the timer overflow also. And these are the following characteristics and operations of mode 2. It is a 8-bit timer, you need to say first, and then it will be having a values in between 00 to FFH, and then timer registers TH and TL. TL will be loaded with the 8-bit value, and then it gives a copy to TL. Like this you need to explain, and we need to start the timer and the flow go like this. You need to refer this characteristics and the operations of mode 2. And then comes to the steps involved in mode 2 program. Again, we need to load the T mod register, and then it will indicate which timer it is, timer 0, timer 1, which is to be used, and then load the TH register and then start the timer and keep monitoring the flag, that is timer flag, and then get out of the loop when timer flag goes high, means that is overflow. Clear the TF flag and go back to step 4 since it is mode 2 auto reload. This is the steps involved in the mode 2 program, and these are the characteristics and operations. Come to the next question 5B. Analyze the structure of T mod register. T mod is a timer mode register. It is a 8-bit register of microcontroller. It will control the mode of operation of its 2 timers, timer 0 and timer 1. You can see in this structure timer 0 is there, timer 1 is there, and you need to indicate what are all the fields in the timer 1 and timer 0. There are 4 modes, 00, 01, 10, 11 indicating different modes, and also you need to explain what is gate as well as C bar T, that is timer or counter. Then the next question is explain RS-232 standard and the 9-pin DB connector. So the 9-pin DB connector indicate it is having 9 pins. You can see here there is a connector shown. You need to write this diagram like this. So here indicating 5 pins at the top, 4 pins at the bottom. Starting with this pin is 1, 2, 3, 4, 5. It goes like this, and 6, 7, 8, 9. Each and every pin will be having certain functionality. Pin 1 will be a data carrier, detect. Second pin will be receive data. Third pin is for transmit data, and goes on. And you need to explain this as it is mostly used for serial input output interfacing, and it is a standard represented as RS-232, and the voltage values are like this. It will be used for certain functionality. You need to indicate that. Since it is for 4 marks, this much of explanation is sufficient for this. Then the next question 6A is write a C program to transfer S serially at 9600 baud rate and 8-bit data, 1 stop bit, do it continuously. Here in this answer I have given the C program as well as the assembly program. You can see at the left, this is the C program required as an answer to this question. At the right side we will be having an assembly level program. In your exam you may get C program or assembly level program asked to write. So I have given both the answers here. You just refer to the assembly level program also, so that if they ask to write ALP you can write this. Or for this particular question you can go with this C program. Here you can see tmod and th1 need to be load first, and then SCON tr1 to start the timer, and then we need to pass YES. This is how the C program goes. Similarly in the assembly level program also you can relate this. This is the answer for write a C program to transfer S serially at 9600 baud rate with 8-bit data, 1 stop bit, and do it continuously. The next question is on TCON. TMOD, TCON are very important registers. So you may get this question in your exam. TCON register is also a 8-bit register in microcontroller. This controls the timers in the microcontroller. It will be used to start as well as start the timers, and also it contains the bits to indicate if the timers are overflowed or related to interrupt related bits also there. You can see the 8 bits here starting from LSB to MSB. LSB is TCON 0, MSB is TCON 7. So totally 8 bits. And also the addresses you can see here starting from 88 to 8F. Each and every bits can be accessible. It is bit accessible. And the different content of the registers indicating each and every bit indicating certain functionality, you need to explain those. Here you can see the what happens if it is bit 0, bit 1 is clearly explained below with respect to interrupt. Then comes the next question is on serial communication. Explain full duplex, half duplex and simplex in serial communication. Simplex in the sense, as we say, suppose two people or two system are communicating. So let us consider A, B. So A is a transmitter and B is a receiver. Means A can't receive and B can't transmit. That will be called as a simplex transmission. It is like FM. You can see FM receiver will be our system. We can receive the FM audio, but transmitter will be a FM station. So that is a simplex communication we can say. So through the receiver we can't transmit back to them, right? That is a simplex communication. Half duplex communication in the sense, both the systems will be having transmitter and receiver capability, but at a time we can't do both. Once we can transmit from A and B will receive, and B can transmit later and A can receive. That is how half duplex communication occurs. Full duplex communication in the sense, it is like a phone call. We can talk together so that we can able to receive as well as transmit. So these are the 3 types of serial communication. This is also a very important question. Since it is asked for only 4 marks, this diagram and a little bit of explanation is sufficient. But this question can also be asked for 6 marks, where you need to write a little bit more explanation related to this. This is about module 3 questions. So here TCON, TMOD are very, very important, and also mode programming, what are the different modes can be asked, and also one programming question can be asked like this. This or any other question you can get. Practice the programs also. And TCON, TMOD registers, as I said, very, very important for exam. The 4th module question, explain the structure of interrupt priority and interrupt enable register. Here 2 registers are asked related to interrupt. This interrupt priority register contain 8 bits. These 8 bits are corresponds to setting or resetting the priorities. So you can see over here PX0 corresponds to external interrupt 0 priority bit, and similarly PT0 with respect to timer 0 interrupt priority bit. Similarly we have 6 bits. Other 2 bits are reserved. It is not used over here. It will be for the future use. And similarly the next one is interrupt enable register. Here also EX0 to ET2 corresponds to enable or disable that particular interrupt, and EA is very important here. EA is enable all. It must be set to 1 in order for rest of the register to take effect. So this is EA indicating enable all. Then comes analyze interrupt control used in 8051 question. So this question asked to explain or analyze interrupt control used in 8051. How actually the controlling of the interrupts will be happen in 8051. So this is the answer which I am put over here. Please cross check this answer once. Why? Because analyze interrupt control, in the sense this is a general question. You need to answer in which are all the different types of interrupts there, and how actually those interrupts are going to be handled through interrupt service routine, and what happens when the interrupt is activated. So that is what which I have given over here. This is related to the interrupt service routine, and these are the different types of interrupts we can enable and disable, and this is the steps followed once the interrupt is activated. Please cross check this answer once. If you have a better answer, please comment below, or if this answer is correct, also please indicate in the comment section. Explain how multiple interrupts are handled in 8051 microcontroller. So if multiple interrupt occurs, that need to be handled carefully one after the other. So to handle that, microcontroller having a facility called priorities. So the priorities are assigned according to the sequence given in the table. So this is the table indicating the priorities, which is highest priority for the external interrupt 0 and lowest priority for the serial communication, like that. So external interrupt 0 and then timer interrupt 0 will be the highest priorities, and then external interrupt 1, then timer interrupt 1, and then serial communication. So these are the interrupt priorities, highest to low, it is mentioned over here. So this is the way the multiple interrupts are going to be handled in 8051 microcontroller. Then list the steps involved in executing an interrupt. Once the interrupt is activated, this microcontroller 8051 will follow certain steps in its execution. While it is executing certain instructions in a main code, it will be having the next instruction of that main memory in a main code in program controller. So first program controller next instruction address need to be kept carefully into a stack. That is the first step, and then it will come to the interrupt, and it will serve the interrupt according to the interrupt, and again it will go back to the program counter address and it will carry the instructions. So these are the steps microcontroller follow. You need to go through this and you need to explain neatly stepwise for this 8 marks. Then explain interrupt vector table for 8051 microcontroller. Interrupt vector table is shown over here. You can see these are the different interrupts, and then you have the addresses corresponds to that, and the pin locations for the external hardware interrupts. Pin 3.2 and pin 3.3 corresponds to external hardware through INT0 and INT1, and these are the RAM address locations. So interrupt vector table is it is a data structure that links a list of interrupt requests with a list of interrupt handlers in a table of vectors. So that is what interrupt vector table is. You need to explain how actually that works and what are all the addresses and the different interrupts, and also the pins related to the external interrupts. The next question is on explain the steps involved in programming serial communication interrupts. So initialization of serial communication interrupts. So configure the serial port control register, that is CISC, to set mode of operation, and then enable interrupts, and then write interrupt service routine, and then the main program loop will be started. So these are the basic steps involved in programming the serial communication interrupt. Then from module 5 we have a programming question. Write within a diagram, write an assembly language program to interface stepper motor to 8051 microcontroller. You can see the diagram here. This is the unipolar stepper motor, and it need to be interfaced with a driver ULN2003, and these are the ports need to be used, and this is the program you can see for the interfacing of stepper motor to the microcontroller. You can go through this. And then we have another question. Explain the interfacing of DC motor using C programming. Here the C program is asked to interface a DC motor. Here also DC motor need to be connected through this motor driver to the microcontroller. These are the ports and the connections you can see. And this is the C program. Go through this. Anyhow, comments are given here in detail for the understanding purpose. And then the next 10th A question. With need diagram, write an assembly language program to interface LCD to 8051 microcontroller. So here a 16x2 LCD is shown in the diagram. These are the port connections for the 8051 microcontroller. And here is the assembly language program. It requires command subroutine, data subroutine as well as delay subroutine over here. And this is the code for the interfacing of LCD 16x2 with 8051 microcontroller. Then the last question is explain DAC interface with diagram and also write a program to generate staircase waveform. So this is the diagram again for the interfacing of DAC to generate the staircase waveform. And here is the code to generate, here is the program to generate 5-step staircase waveform. Here the accumulator can have maximum value of 255 to get 5 steps. So this is shown for the 5-step staircase waveform. If you want more steps or if you want different steps, accordingly you need to give the value for the accumulator. This is about the answers for the model question paper of 8051 microcontroller subject. Thank you.